Hello my dear children. The next topic in thermodynamic I am going to discuss with you. These are the types of thermodynamic process. So this particular topic, this one is types of thermodynamic process. This one is most important topic because if we came to know what are the types of thermodynamic process are there, and according to that conditions we can maintain, or we can consider some conditions given in that one. So there are four types of the thermodynamic process are there. The first one is that isothermal process. See here, isothermal process means it is a process. Actually the term iso means same, thermal means temperature. It is a process which takes place at constant temperature. So I should say it is a process which will take place at constant temperature. When it takes place at constant temperature, obviously the delta T value should be equal to 0. And if delta T value is equal to 0, isothermal process. And one more point you remember, this is a very important point to remember in our IIT point of view. In mains they used to ask, if the isothermal process it is for ideal gas, if it is for ideal gas, then this isothermal process for ideal gas means obviously ideal gas isothermal process means delta T equal to 0. With that one we should consider delta E, change in the internal energy, is also equal to 0. Change in temperature 0, change in internal energy 0. Why it is like that? Delta T 0 means delta E 0. So these conditions already maybe you learn in our 11th class, states of matter. It is given in the postulates of kinetic molecular theory, and in that postulates of kinetic molecular theory they have given such a way that kinetic energy of the gas molecule is directly proportional to its absolute temperature. And we know kinetic energy for ideal gas is nothing but the internal energy. So as the kinetic energy directly proportional to absolute temperature, that means kinetic energy is directly proportional to internal energy. Hence delta E equal to 0 means delta T also equal to 0. For that one we can plot a graph, pressure against volume. Let us say pressure against volume, the graph which we want to plot here. So in this case for isothermal, if we are considering delta T is equal to 0, we are getting the rectangular hyperbola graph. This graph is called as a rectangular hyperbola graph, and this graph is only for isothermal process. So this is one of the important types of thermodynamic process that we have seen here. That means isothermal process means the process which takes place at constant temperature, delta T 0. If it is an ideal gas, delta T 0 means delta E equal to 0. How it is a delta E equal to 0? This part we have taken from the kinetic molecular theory, that is important postulates of KMT, kinetic molecular theory. Pressure against volume, if we take, we are getting the hyperbola, rectangular hyperbola graph, and this graph is only for isothermal process. It is the first type of thermodynamic process. Second type is that isobaric process. Second one is that isobaric process. Isobaric process means it is a process which will take place at constant pressure. That means delta P equal to 0. The process which will take place at constant pressure, delta P 0. And one more point you should remember, all chemical reactions takes place at constant pressure. That means delta P equal to 0. If you want to plot a graph pressure against volume, for this one pressure is constant, so this is a graph we are getting for constant pressure. So it is a graph for isobaric process. And now third one we are going to see about isochoric process. And third one, isochoric process, a process which takes place at constant volume. Process which takes place at constant volume. That means our delta V equal to 0. And this in that very simple way, if you want to plot a graph pressure against volume, we are getting a straight line, no change in the volume. Initial, final, both are same, equal to 0. Delta V equal to 0. And fourth one is that one more very important process that will be called as a adiabatic process. The process in which no heat exchange. The process which takes place where no heat exchange will be there, that will be called as a adiabatic process. That means our delta Q is equal to 0. Remember beta, if they will give for you cyclic process, just they will give cyclic process, pressure against volume. And we started from this point, 1 to second, second to third, third to fourth, fourth to come back. In this process, can you tell me our delta P equal to 0, delta Q equal to 0, or it is not equal to 0? In this case, our delta Q is not equal to 0 because delta Q, that Q is called as a what? Path function. It is not the state function. But if the thermodynamic process which will take place at adiabatic, means the adiabatic process if they mention, so there will be no exchange of heat. That part is variables, these are the nothing but the process. So the process, if it is adiabatic, in that one there will be no heat exchange, so delta Q equal to 0. And in this particular case, delta Q equal to 0, if you want to check here a graph, pressure against volume, here also we are getting the graph. This graph will be called as a graph for adiabatic process. Now we people are getting the doubts, sir, the same graph we got in the first thermodynamic process, that is where isothermal process. What is the difference between this isothermal and adiabatic? So it's a very important point we should remember. This is a slope for the adiabatic and this is a slope, it is for isothermal. Means if you want to compare the isothermal with the adiabatic, the deep slope we are getting for adiabatic, but above it we are getting for the isothermal. So this is an easy way to differentiate between the isothermal and the adiabatic. So these are the four important thermodynamical processes are there: isothermal, isobaric, isochoric, adiabatic, where in which case we should take the delta T equal to 0, delta P 0, delta V 0, delta Q 0, and how to remember the graph. So graph means it is a very simple way. If it is a pressure against volume is given, it is for isothermal. If it is a pressure against volume is given, then we are getting this one for isobaric. If pressure against volume is given, this graph we are getting for isochoric. And if it is a pressure against volume is given, this is the graph we are getting, it is for what? Adiabatic. And comparison for this adiabatic with isothermal, it is a simple way to compare. So these are the very important topic of the types of the thermodynamical process I have covered here. After this one we are going to see the next important topic related with that one, that is reversible process and irreversible process. What is the difference and what is the actual mean and use of these reversible, irreversible in our thermodynamical process. This one we are going to see in our next video. Thank you my dear children. Thank you very much.